How's everybody doing today? Good conference? Hopefully I'll get the chance to attend next time. I just showed up today from Denver, so bear with me a little bit. But everybody hopefully is in the right room. I know I look really strange, but this isn't the Dr. Strange screening. This is Json on Json. So we're going to talk about Json. And since my name is Json, I'm probably the foremost expert on Json. So I'm the right person to talk about. So how many people in here are developers? Is this primarily a developer audience? Just hands maybe? Most of you guys? Any DBAs or data people? A few, okay. And are you guys, is everyone here kind of currently working with a lot of JSON? Okay, and are you guys storing it in databases or just in the app? What databases? Oracle, SQL? Postgres? Oh, okay, interesting. SQL Server, okay. Azure SQL DB or SQL Server on-prem? On-prem. Okay, GCP, cool. So we're going to go through this. It's a pretty basic level talk, but feel free to interrupt me, ask questions as appropriate, so welcome. A little bit about myself. So as I said, I'm based in Littleton, Colorado. My name is Jason Horner. I run a small consulting practice. I do a lot of consulting around data. I used to be an MVP, Microsoft Certified Master, have a bunch of other certifications. We don't really care too much about that. Again, primarily in the data warehouse BI space, so a lot of data engineering. A little bit of a background in PowerShell and traditional dev long ago and far away. I used to be able to do ASP websites, but that's no longer a thing. Definitely connect to me on LinkedIn. Follow me on Twitter if you want, and feel free after this to reach out with any questions you have about using JSON or any topics that you think I might be able to answer. If I can't give you an answer, I'll give you double your money back guarantee. So the first thing to understand is just a little bit about data types, and I only really have, this is my last slide, so you know, when I think about storing data in a database, that's really structured data, right? I have rows, I have columns, I have tables, and I have relationships between those entities. But there's other types of data, and so JSON really falls into this category that I call semi-structured. Some people might call it unstructured, but there is a little bit of a structure there, right? And the kind of dirty secret in the data world is that all data really has structure. So even an Excel file or a JPEG file or a PNG, Word documents, PDFs, they all have metadata, right? They all have structure. So I'm sure some of you guys have probably written code to pull data out of those kind of unstructured sources, but all data really has structure. But what we're really saying here is it's not relational, right? It's not neat, it's not in rows and columns. Anybody that's ever had to import a CSV file is going to know the pain of dealing with that file format, right? There's many different standards out there and nobody seems to follow any of them. But we're really here to talk about JSON. And so JSON is really good for storing document-oriented data. But there's a couple other use cases, especially within the database world that we can talk about. And then obviously XML is kind of another kind of markup language. I kind of view JSON and XML as similar. That's probably oversimplification, but they're all kind of markup languages in my opinion, but your opinion may be different than that. So any questions about that, about data types, or why I spend a bunch of time talking about it, why it's important to understand? Okay. And hopefully everybody can read that and see that. Does it look good in the cheap seats? Okay. So a little bit about the agenda. We're going to talk about JSON structure, which should be pretty basic for everybody, but I want to make sure everybody's kind of on the same foundation. We'll go over some use cases where it makes sense to use, where it doesn't make sense to use, which is more important. And then we'll talk about the primary functions inside of SQL Server to manipulate JSON, which is JSON value, Json Query, Open JSON, and Json Modify. And then a couple miscellaneous tips and tricks, some performance stuff, and then loading JSON into SQL, different ways there. So a little note about the tools for working with JSON. So I'm using Azure Data Studio. Is anybody using Azure Data Studio to work with SQL Server? So a couple people. Lots of other tools. I could have done this in Management Studio. It's in an actual notebook right now. So if anybody's heard about like Jupyter notebooks or Python notebooks, this is actual notebook file. This whole entire session is in this notebook, and it's all up on my GitHub, and I'll provide a link to that at the end of the session. So you can actually take this code. There's not really many database dependencies, so you can run this code and play with it and kind of check it out. So with that being said, And then just another note, so Azure Data Studio is a tool. I also sometimes use VS Code to format JSON, but there's also web-based JSON formatters, and probably any IDE that you guys work with will have that as well. So a little bit of note about JSON structures. So data is primarily in name-value pairs, right? Data is separated by commas. So if you're manually typing this, it's really easy to get the structure kind of messed up. So it's definitely good to use an IDE and formatting and keep everything good. Curly braces will denote objects, and then square brackets will hold arrays, right? So the cool thing about JSON is it's a very hierarchical structure, meaning I can nest objects that can have properties, or they can have other objects, and then those objects can have arrays, and there can be properties, and it's pretty powerful. It's a very robust way to express data. And then there's some data types, right? So if we think through this a little bit, string is the basic data type, right? All data at the end of the day can be expressed as a string, so that's an important concept that we'll come back to a little bit later. So strings are always delimited with double quote marks, and there's escape characters. An interesting thing to note in proper JSON, and we'll see an example of that, is it doesn't support comments. Now, your language or your IDE may make you think it does, but the actual standard doesn't have a comment in it. There's numbers, so we can have ints, decimals, floating points. You'll notice that a number is not going to have any quotation marks around it, okay? Then an object, like I said, are just these braces, these curly braces. An array is just going to be the square brackets, and then we can have a Boolean value of true or false. And then we can assign null values, but typically in a JSON document, you won't see null data types. They'll just omit the property. So, and that can be problematic when we think about semi-structure. That's really one of the big things is in a SQL environment, I know that every row is going to have a value. It may be null, or it may be a blank string, or it may be actual string that says null, but every column is going to have, I hope not, but every column is going to have a value, and that column is going to be present in every row. In JSON, I may have one object with 3 properties in it, another object with 2 properties in it. There's no schema to it, right? Unless you as a developer or you as a database designer or data modeler, unless you enforce that. Okay, so here we have, and it's important to note that it should start with a curly brace. Now this is what's called document-oriented JSON. There's also line JSON, which you can have multiple records in a single document, but we're just going to focus on this format. So there's an actors object. It's actually an array, right? Within that, we have kind of a name property, an age, born, birth date. Interesting to note, what data type isn't present here that you would typically see? Any ideas? Somebody's got to be brave. I can't see you, so you can just yell it. Date. Yeah, there's no date or date time, so it's got to be a string. So that can cause problems, right? Because how many people think that their coding language can parse this date? Probably not, right? Not as a date time in SQL Server, certainly, right? Without some formatting magic. We've got URLs in here. Here we've got a null value for wife, which I think is probably the Will Smith scenario pretty soon, maybe. Oh, and that is the rule. No one's allowed to come up and smack me, so let's get that off. Sorry. Null values, true and false, right? And then here I have an array of children, right? So it's just a collection of data. And that's pretty powerful. I can express a lot of different objects in here, very complex object hierarchies, object graphs. And JSON is really, if you were to go back maybe 10, 12 years ago, XML was getting all this traction, but it could be really cumbersome to work with. There were a lot of different other XML standards like XSLT, XSD, different flavors, different parsers. This is kind of more natural, but I would almost say that now that you're seeing things like YAML kind of become more of a common language, but JSON's still got a pretty big base out there, and it is kind of the language of the web still, right? So if you're working with a REST API, 9 times out of 10, you're going to be working with JSON, right? There might still be some XML APIs out there, but most of the time when you have a REST API, you're going to get JSON back. Any questions about the JSON object itself? Hopefully that was just a review for most folks. Yep, we covered all that. So what are the use cases? And specifically, I'm not going to talk about like in your app, right? But I'm going to talk about in the database backend. So from a data engineering standpoint, or from just storing data, right? And so the first thing that I really like it for is flexible logging. So anytime that you're writing logging information to a database, now you can argue, is that the right thing to do? Is it the wrong thing to do? There's better technologies for that. But a lot of times you'll see quick and dirty logging going out to the database, or even the database ingesting logging for reporting or analytics, right? And specifically, we're talking about SQL Server. And so, but the log entries themselves, depending on the context of that log entry, might have lots of different properties. And so traditionally what people would do in SQL is create kind of sparse tables, right, with lots of columns. So you'd have like a column with 255 columns, and depending on what kind of logging record it was, the certain values or sets of values, subsets might be null, might not be null. What JSON allows me to do is create one column, call it activity log, and have a flexible schema that I define on the app. And then as that schema evolves, right, as it evolves over time, I can change it up, and as long as my code still knows how to kind of deserialize that object, whether it's via T-SQL or if it's on the client side from a programming language, or, well, T-SQL is a programming language. You guys might argue differently. But the point is I can change that, I can evolve that schema over time. It's not gonna break anything. And I don't have to go in and I don't have to have this friction where I'm changing the database schema, right? Because how many people as developers have had to wait an inordinate amount of time to add or remove a column from a database? Because the DBAs are really mean and nasty, right? So this allows you, if you put some thought into it, to create that flexible column structure. Now, it's kind of like Spice, right? You don't wanna overdo it. You don't wanna use it too often, which I'm gonna talk about in a little bit as well. The other pattern is when you have type subtypes, right? So if I imagine I'm Amazon, I'm selling orders. Well, I may have a product catalog or a book catalog, and products may have different types. Like a book may have certain types of properties, or a movie might have different properties. Different groceries might have different properties. And so what I can do is I can use that JSON column to do the type subtype. Traditionally in a database, what I would do is I would have one table with the common attributes, and then I would have a bridge table that says, okay, there's these different types that I'm storing, and then each subtype has its own table, and those attributes are structured. But if I go to add a new one, now I've got to I probably have to alter a constraint somewhere, and then I have to add a new table and wire that all up. With JSON, I just create the new schema, put it in the database, start inserting data, updating it, reading it, and as long as the code knows how to handle it, everything's fine. So that's the second major pattern. Configuration values is huge. So anytime you're gonna do metadata or code gen or application configuration, using JSON to store that rather than to have a strongly typed configuration table, as long as that format's well documented, so you can't forget to document the structure of these, because again, there's no schema evaluation, but that can be a great use case to kind of reduce the amount of extra columns, the sparsity, and make it easy to change that configuration or add new entries as it goes over time, right? So one of my big use cases, aside from the logging, is to really, when I'm building data pipelines, I make as much of it metadata driven as possible. So I have a very limited amount of data pipelines. They all use metadata, and they all pull it from a control table that stores JSON that describes what kind of transformation am I doing, right? So I'll have a sink, I'll have a source, and I'll have a transform, and that's all wired up via metadata, and my pipelines know how to work with that and do the right thing, okay? So the final kind of thing is document-oriented models, right? So I would use this one sparingly. So SQL Server fundamentally is not a document database, right? So something like Cosmos DB or other NoSQL solutions out there are better at that. But if your use case is 80% or even 60% transactional, but you do have some document-oriented use cases, then this can kind of help bridge that gap, right? Rather than just saying, okay, I'm going to store some of this data in Cosmos and some of it in SQL Server, which you can do, and it may make sense in like a microservices architecture. But me being a data guy, the database is kind of the one store to rule everything, and so I want everything in one database if possible, right? Where it makes sense. So what I wouldn't advise is if I was doing a lot of transactional updates to the properties of those documents, then it's maybe not such a great case, right? If I'm doing a lot of complex searching on the properties of the documents, I'll show you guys later, there's some things I can do to improve that performance and experience, and there's some nifty little tricks. But overall, this is for kind of light use of document-oriented models, okay? And so some of the data that you might be seeing as sources, IoT, right, might send data in. It might come natively as JSON through REST APIs, logs, different protocols out there kind of rely on JSON. And then some alternatives, right? So we talked about the NoSQL DB, so like Azure Cosmos DB. XML data type could be an alternative. I don't think I would move forward with a new solution on XML at this point, but if my legacy environment is still using XML, then maybe it makes sense. A lot of ways, JSON and XML kind of have similar functionality from the database level as far as storing semi-structured data, but there's some pros and cons for both of those. And then don't forget about traditional data modeling techniques, right? So this is not an excuse to just not do data modeling and create one table that has data, a data column, it's JSON, it can be whatever you want, and stick an identity on it and go. Like, that's not gonna ever work for anyone, right? Maybe in a class somewhere at a school. So entity attribute value pattern is a pattern where I have attributes that are flexible, that are stored in kind of a child table, and there's a many relationship. There's a bridge table on top of that, and then I can query and say, okay, this object has these 3 values, whereas this one has these 5, and I can do joins to get it back. I can filter on the attributes, and it's strongly typed. So that's a pattern to investigate if you need to store sparse data or data that's kind of polymorphic in nature, right? Many to many, again, same kind of pattern here, different use case for different scenarios. So definitely look and see what you can do in the relational realm before you give up and punt and say, okay, I'm gonna go use JSON or XML, or I'm gonna use Cosmos DB, right? So there's really, like I said, there's those primary functions, right? So I have a JSON column that's in my database, and I have to fundamentally do 2 actions. I either have to get the JSON into the database, so convert the JSON to relational, in which case I could do an open JSON to start inspecting it, or I can do JSON value or JSON query. Or I'm trying to reproject the data out as JSON for some client API, and that's where I can use the for JSON functionality, okay? Interesting to note, support for JSON was added in SQL Server 2016. It's also supported in all versions of Azure SQL Database, so managed instance, and just regular SQL DB and the different variants and SKUs and tiers, so you don't need like a specific performance level or anything like that. Like, it'll work with all SKUs, all tiers. And then Azure SQL Synapse Analytics recently, as of, let's say, 2.5 years ago, added JSON support, which you kind of say, well, why do I need JSON support in my data warehouse? It maybe doesn't make sense, but there's some of those use cases there are used for that. Now, I will say, if you're primarily trying to do log analytics, you definitely want to look at something like Azure Data Explorer or Elasticache or something like that that's more meant for log querying, right? So, but this can work for certain scenarios. Questions? Does that all make sense? Okay. So how do we store JSON? So I've got a couple options, right? I can create a table here. I'm gonna put you always want a primary key on the table. It doesn't, and you should spell it right, not indentity, which should be identity, right? But nonetheless, I'm gonna create a field here. I'm gonna call it movie data, and it's gonna be a varchar max, right? So a varchar max, if I'm just storing, American characters, or an nvarchar if I need to support international character sets, right? Other collations, so on and so forth. We'll support up to 2 gigs of data, right? So that sounds great, right? That sounds like a free lunch. I can put as much data in there as I want. Everything will be good. The price to pay is that once that data extends beyond the boundary of an 8K page in the database, so the page is, a table is kind of, a set of data, and the table under the hood uses a bunch of pages to store the data on. Once it grows beyond 8K, it stores it off-row, and so there's a performance hit for off-row data. So if you don't need varchar max, don't use it, right? I'm not saying don't ever use it. I'm just saying if you know that, for example, somebody's first name is never gonna be more than 200 characters, then do a varchar 200, don't do a varchar max. So just like JSON, if you know your data is gonna be big, then go for it, knock yourself out, right? If you know that it's gonna be fairly small, then you can use varchar 4000, or you can use, nvarchar 4000, because it's bit-based, so it's gonna have half the capacity of a varchar field, which will be 8000, right? So either of those 2 data types,
There's not really a huge benefit from SQL Server standpoint to doing like a varchar 200 versus a 4000 because it's gonna store the data just in the space that it actually occupies. So the amount of bytes plus the pointer is gonna be how much data is stored at the database. Now I'm not saying to go out and model all your varchar fields with 4000 and 8000 by default, but for JSON data, this would be the choice I would make. I would say either use a varchar max if I know I need big documents. If I know I need small documents, use a varchar 4000 or 8000, depending on if I need national character sets or not, okay? And we'll talk about, I can put a constraint on this, we'll talk about that in a little bit, but this is just kind of showing you. Now the other thing, this is where it differs from XML as well. So notice it's just using a varchar data. There's no JSON data type in SQL Server, right? So that's kind of interesting, right? And whereas XML, if I want to store true XML, there's an XML data type. I can also store XML inside of a character column, but I'm not going to get any fancy support for it. Another cool thing that I bet no one in this room has heard of, do people know that you can do Gzip compression within your database using compress and uncompress? Has anybody heard of that before? One person? Okay, all right. I was wrong. So anyway, that's pretty cool, especially if I have big JSON data sets that I'm only going to query to return to the data. I'm not going to filter it on it. I'm not going to search on it. I don't need to index it. As soon as I use the compress and decompress, and how that function works is I just call compress. It's just a function around that string value or that character value. So if I have like large comment fields in my database that I'm never searching on, but I need to return as a record, I could compress that data, save myself some storage, and I can decompress it and come back. Okay, so I'm not saying that that's like this super crazy performance technique you should use everywhere, but it is an option, especially when you're dealing with large data types, and it works with JSON. But once you compress the data type, it uses a different, it uses a var binary max as opposed to the varchar, so you don't get the benefits of indexing on it. Okay. Ooh, what do we do here? All right. So if I just want to grab, let's say I have a JSON object and I just want to grab a value back, a scalar value, which means what? One value, right? I can grab that back using the JSON value function. So let's inspect that. So here is me creating a JSON data. Notice I'm using nvarchar max. I could have used varchar max here. I could have used varchar 4000 or even 200. That would have been fine. The N, the capital N here, means it's a Unicode, or it's going to treat it as a national character set. I've got my JSON object here as a string, semicolon. You should always use semicolons in SQL. And then I have this isJSON function I can run to check to see, is this valid JSON or not? So that's always a good thing to do. And then I can run this query here to say, I'm going to call JSON value. I'm going to give it the variable or column name. So if this was coming from a column, I would put the column name in here. Then I'm going to use the Json syntax, which is this, which basically says, go to the root of the document, give me the .info property, right? So .info, break into that and give me the address object, and break into that and give me the town, and that'll be Bristol. And then I can go info.address, which is an object. So there what I need to do is a JSON query, right? So if I tried to query this info address using JSON value, depending on what mode I was in, if I was in lax, which is the default, what value is it going to return? It'll be a null, right? If it was strict, it would throw an error saying, hey, this isn't a scalar value. What are you trying to do? It doesn't know how to do it. It's not smart like Python. It doesn't understand duck typing, right? So what I have to do here is make sure that if I'm working with either an array or an object or a portion of an object, that I use JSON query, and that's going to return that as another JSON object that I can further query and filter. Whereas a JSON value just gives me scalar values, right? So if I wanted to get town, county, and country, I would have 3 calls here to JSON value and passing the path for each of them and run it as type, right? We're going to go over the modification stuff later, but does that make sense? It's pretty basic, right? I don't think it's super rocket scientist stuff. And I could try to run it. I'm questioning how well the Wi-Fi is going to work for me, but let's see. Yeah, okay, let's see. Lovely. I don't know why it's not connecting. All right, let's keep moving forward. This would be the result, right? So Bristol,
And this is the advantage of using notebooks. My demos don't even have to work, and you guys will believe me. So, so I've got Bristol coming back, and then I've got this JSON string that I can further enumerate. Anyway. So Json Query, I kind of spilled the beans on that a little bit already, so I'm not going to belabor it too much. But just note here that if I pull this back, I'm going to get this array consisting of sport and water polo. And indeed, that's what I get back. Does that make sense? Okay. So that's all fine and good, but that is really giving me one row per row in the database. What if I have that complex object structure and I want to explode it, right? So if I have either an array of objects and I want to have one row per item in the array, or I want to break the properties out into different rows, then I can use this OpenJSON function. And so let's see, what does that look like? So here what I've got is I've got a JSON document. It's got name, age, and then a cars collection. And that array stores JSON objects with name and then a models with some arrays, right, inside of it. So there's a lot of nesting going on in here, okay? So I can use my JSON value to pull back name and age because those are just scalar values, right? But now look, I'm getting m.name and m.models. Well, that looks like this property and this property. So what's going on to make that happen? I'm just gonna, I don't need to comment that out because I'm not gonna run it. But so from my JSON data, I'm referencing $.cars. So I'm going to, oh, that's a demo fail. There should be a cars collection around this. Oh, no, here it is, I'm sorry. So we're going into cars, and then we're getting, so that's setting kind of our current context, right? And then it's saying, okay, there's gonna be, inside of cars, there's gonna be a scalar property name. I'm gonna cast it as varchar 100. I can cast this as whatever I want, as long as it implicitly works. So I could call this varchar 4000. If it was numeric, I could treat it as a varchar 100, or I could treat it as an int, right? So I have some flexibility there to an extent, right? And then I'm giving it the property. So now, because I'm in $.cars, I'm now seeing name is, or this array as my root. So now it's saying $.name. And then I'm grabbing the models back as JSON. So that's basically returning it as if I did a JSON query on it. And that's key. If I want to get whatever is in here back as a JSON object, I have to use this as JSON as a thing in my with statement here, okay? Now, that gives me this row set here, but you can see I can break that down one more. So, sorry, this is the result from what I was messing with on the plane. Basically, what would happen if I ran that with this commented out is it would give me one row per name and with the models. So it'd give me row 1 here, row 4, and I think row 7. So, but I can also use a cross apply on that, right? Is everybody familiar with cross apply and outer apply? So basically a way to take and apply a join or some kind of operation to a table or a subquery to get multiple rows back when you normally would have one, right? So, and then I'm saying do OpenJSON and m.models, and I can do OpenJSON because I'm coming back as JSON, and then I alias that as ML, and notice here I alias this as M, and then I just do ML star and it automatically knew the names, right? So it does names. So, you know, if I was a good developer, I would probably do something like this, but I'm not, clearly, right? So I would always make sure that I have my columns explicitly named. But that just shows you, and I can repeat that pattern. The more nesting I want to break out, the more exploding I want to do, the more rows I want to create based on the object depth here. It'll allow me to do that. So any questions? Does that all sound good? Okay. Alrighty. So did that JSON value query that we looked at, even though it was pretty small, did that make anybody kind of scratch their head and be like, this looks kind of ugly? Because basically, for each column I want to pull back, I've got to write out all this crazy syntax, right? And to me, that looks ugly. So what I can do, I'll go down. And this is kind of just a standalone query. I'm going to make it big too. So I've got to select, and I'm doing my cross apply. I'm opening the JSON, and I'm going into my transform object. And then, did I get myself messed up there? But what I can do here is, rather than using JSON values, like I've got commented out here, what I can do is just put this cross apply on a single row. It's just going to return a single row because I'm not drilling down into anything. I'm just saying root me at the transform object. This would make more sense if you saw it, but imagine I have a transform parent object, and then inside of that I've got a type, and then type properties. And it's basically going in here and it's grabbing each of these columns. So I don't need multiple calls to JSON value. I can just break that out and see here I've got t.transform type. So then I just reference it, so I'm aliasing it as t, and then I can use these names in my query. So to me, that's a much better syntax, plus I don't have to cast the JSON value. I can put the data type in here and it'll come back as the right data type in SQL. So does that make sense to everybody? So that's, if you're doing 1 or 2 JSON values, then probably JSON value is the way to go. If you're doing more than a couple, I would do this cross-apply open JSON pattern. I think it's much better, and you get casting and it's all in one place. So when you need to go add more columns. And you can see here I can break this down. Like, I'm not limited to operating in my current row context, like I can, or my current context within the JSON hierarchy. I can go $.type, and then I can go $.type.properties and pull all that back. Okay? Finally, let's see how we're doing for time. Ooh, all right, we're doing good. So what if I want to make changes to a JSON object? Okay. So if I want to update, I can call Json Modify. I'm going to use lax mode here, and then I'm going to say, give me this path and set the value there, right? And then what it's going to do, what's interesting is just, this is the nature of how I'm doing things. I'm setting that variable, so it's not actually doing an update to, because there's no table where this is coming from, right? But I'm just setting this. So it's going to return basically a new JSON object. So Json Modify is going to return that value. And if I was doing an update, I would say update the JSON data column, set it equal to Json Modify the JSON data column, passing in the pathing and the new value I want to use, right? So that works with scalar. And then if I pull it back here, this is how I would pull it back. And notice I'm working on this variable which has been changed, right? It's actually mutating it. So I can insert records. So if I want to add a new address, I can create a new address in here. Where do I have that at? So I can just put a new address record in here, and it'll just insert that record. And this could be a more complex JSON object, so I could kind of do this in pieces and bring data in. I can delete data, so I can remove that record from the JSON. Okay. And then the last thing I can do, which is kind of neat, is I can append to an array, right? So if I want to just add a new record to the array, I can say append.info.tags football. Now that means that this array has to actually exist, right? If this array doesn't exist in here, it's not going to do anything and it won't throw an error. So that's kind of a gotcha to be aware of, okay? So those are my manipulation operations I can do on JSON. And then these are just kind of the results of the queries, right? Which you can't really see too much because I don't think it's going to come out. So another thing that you can do is, let's say I have a bunch of JSON files sitting on a file share somewhere if I'm on-prem, or maybe they're sitting in an Azure storage account, and I want to load those into SQL Server. And this works for on-prem, and it also works for Azure SQL Database. So I create a master encryption key. I don't have to provide a password. I can if I want to. I create a database scope credential, and I'm going to use what's called a shared access signature, a SAS token. And that SAS token, basically, I can generate that from the Azure portal if I'm using Azure Storage. But it basically is going to encode what kind of access I have, how long is it valid for, and what operations I can do in this like little magic secret string, right? And it actually encodes the location of the storage account and all that other stuff. And then once I create that credential, and there's a couple different ways I need to do it based on how I'm trying to access the data. So I just kind of show for blob storage, right? There's a different URL than there is for ADLS or Azure Storage Gen 2. But then I can create an external data source, and I can call it a name, so DS blob storage. I give it a type of blob storage. I give it a location, which is a URL to where that data is stored. So in this case, it's in the JSON account, and then the name data. And then here we go is another storage account, and this is the ADLS. So it's using a different, it should be using a different endpoint. It should be using dfs.core instead of blob.core. But one of these was a Gen 1 account, and the other was a Gen 2 account. And then what I can do, and this is really kind of where the magic happens, is I can use this open row set command, and then I'll say bulk, and then I'll pass it the name of the file. So in this case, there's a mock_data.json file that lives in this folder, or in the folder for the URL here. I'm giving it the name of the data source that I created. So I actually created an external data source, right? And then I'm going to call it single clob, which just basically means there's a JSON document in that file. So I can't load a directory. I can just load a single file at a time. And then I call open.json on the bulk column. That's just giving a name to the column. So it's really just going to take whatever's in there. I can call this whatever I want. But this is how I know how to alias it in SQL. So if I said, instead of saying select star, I could say select bulk column from this open row set. It's going to load all my JSON into an object. So that's kind of interesting. And then what I can do is I can further shape that. So I've got my open row set here, right? Now I'm cross-applying open.json on the bulk column, and I'm saying, okay, give me the ID property, give me the first name, give me the last name, and return it as a select statement, right? Now I can create a view on top of that. Anything I can do with a table, this is basically returning a table expression. So that's a powerful way. I don't have to use SSIS. I don't have to use Azure Data Factory. If I just need to load small JSON files, I can do that, right? And then I can also do a bulk insert if it's in Azure, right? So this also works on-prem. Obviously, it won't work with an Azure data store. What it does is it works with a file path that's local to the server. As long as the SQL Server service account has access to it, I can just open row set, give it the path, and I'm off and running. I should probably put an example of that in there, but I don't do a lot with on-prem anymore. So, right. So if I'm in Azure Storage, I can create a table, right? And then I can use this bulk insert command into the temp table my data from the file using this data source, and that'll just insert that column in there, and then I'll get the rows back, and or it won't be rows, it'll be a single JSON data, right? So that's how I can insert it. So this just allows me to query it. This allows me to actually insert it or load it into a table. And it doesn't have to be a temp table, right? It could be whatever I want it to be. Okay. So that was all about kind of getting JSON, working with JSON that's already in a database. What if you need to send JSON out of the database, right? So that's where the for JSON auto can come into play, or for JSON path. So if I don't care, right? If I'm a typical developer, I usually don't care about how things look or what the interface is. I can just say for JSON auto, and it'll automatically create me a JSON object, right? It'll be very flat. It'll be basically a property per column, and then it'll have multiple rows, and it'll return it as an array with a wrapper, right? So it'll have an outer document, and then an array. Each row will be a member of the array. Each array will have a property that matches my select statement here. Okay, so that's for JSON auto, and let's see if I have an example of that in there. So that's pretty much what it looks like. It's pretty ugly. But if I want to take control of the shape of that data set, it's actually pretty elegant. I can just say select, and then I can do this as ID, and it'll come back and it'll give me an ID column, and then it'll give me a first column and a last column, and then it'll go here, and I say password.hash. It'll actually create a new object called password and set the hash property to this column value. So I can create this in any arbitrary shape without a lot of extra work, right? I just need to make sure it's pathed appropriately, and it'll all work out. Now there's some more advanced scenarios that I don't go into, like if I want to join header detail rows and create arrays and do things like that. That requires a little bit more work. I have the option to turn on include null values. If I'm going to use this JSON as part of an intermediate result set where I'm going to append it to another JSON document or use it as a part of another JSON, then I could say without array wrapper, and it'll just return me an object. It won't have that little array bracketed wrapper in there. And then I can also name the root element. So if I specify root, it'll basically say, call this the customers object, and it'll have properties customer ID, or it will actually be ID first and last, so on and so forth. Okay. Just something to note, the syntax is a little bit interesting. So if I need to create a function that returns JSON back, what I want to do is wrap that select statement inside of a return with brackets around it, and that'll allow it to come back from the UDF in a result set that the client can understand and know about. And I kind of already showed you this, but an example of how to return it to a variable. We kind of already looked at that, right? It would just be that select for OpenJSON as opposed to just setting it to a string. So those are two ways to do that. Let's see. Certainly that's not the end of the story, is it? Okay. So this is kind of a cool trick that you can do. So oftentimes you want to pass in an array of values like, give me all the orders that are in status canceled or closed, right? Or give me all orders that are in open, active, or pending, right? So I can't just say where the value equals X. I have a list of values. There's multiple ways to do this. But what's cool here is I can actually use the in clause, and I can pass the values I want to query for in as a JSON array. So this is a valid JSON array, right? All I need to do is wrap it in brackets, and it's going to treat that as JSON. So now I have an array in SQL Server, which used to be the realm of Oracle. Like only Oracle could do with arrays. In the past, what you'd have to do is create a table type and pass it in via table type, or you could pass it in as XML, or you could do a comma-separated list. But the problem with the comma-separated list is that it's brittle. Like it relies on somebody knowing how to properly comma-separate a string, which you guys might find is a strange skill that some people lack out there, but I've worked with some pretty interesting developers in the past. So anyway, point being is we take this as a array of JSON. I pass it in, and then I interjoin. I call OpenJSON on my search options as category, and then I do a join here, and I say on p.category_id equals category value, and then that will filter to just these three values. And now, obviously, if I need to do an outer join, I could do that, right? I could wrap this in another function. I could do lots of things there. But this is a pretty cool, and the query plan that you're going to get for this is actually pretty good. Obviously, if you have thousands and thousands of records, it may not scale so well. But if you have 8 to 12 records here, this is probably a great pattern to do dynamic searching or multiple search options. I shouldn't say dynamic searching. So I think that's really cool. Anyway, that was the query results of that. So a couple things that we alluded to earlier, but we didn't talk about in depth. This is super important in my opinion. Anytime you create a database table, you always want to have good check constraints in place. So if I know something about the data, if I know the value is only going to be positive, I'll create a check constraint that says the data is greater than 0. Here what I'm doing is I have a JSON column in here called JSON data, and I'm running the function isJSON and making sure that it returns true. And so basically what this is doing is not allowing me to insert any invalid JSON into this table. Then when I go to write a query against it, I don't have to go back and check to see, oh, is this valid JSON before I try to query it. I just know that it's going to be valid JSON. So that, I would say, is table stakes for every table that you create, is that's going to use JSON data, put a constraint on there, right? It'll save you a lot of time and frustration. If I'm doing searching on certain values quite frequently in the JSON, I can create what's called a computed column. Now, this isn't persisted, but I could create it as persisted. And then once I create this as this expression as a computed column, then I can put an index on it, right? So here I can create an index on that value. So if I do a search where customer name equals JSON, it'll actually go in and do a seek as opposed to a scan, right? Because we've kind of put an index on this function. It will generate statistics on it, all the good things that I would expect from having an index on a column to help with searching. And then just a note here, if I wanted to cover a complete query scenario, so I could create a covering index where I add columns to the customer name. So if I'm returning a query that searches by customer name and returns the sales order number and the order date, this query covers it, and it doesn't have to go do bookmark lookups. It goes directly to the index. Very efficient way to answer a query. Okay, questions about that in general? Okay. In a scenario, especially where I'm not doing a lot of updating of the JSON object, I'll create a clustered column store if it's going to be a big logging table. Put a clustered column store index on it. The reason for that is I'll get up to a 25x compression ratio on that JSON column, as well as the other tables, in addition to having the other benefits of a column store index, which is basically if I select 3 rows from it, rather than doing a page-based B-tree search, it'll scan those columns and efficiently return data back. And then kind of the next thing I can do with this, if I have high concurrency needs, where I'm doing a lot of transactional modifications, even though I told you guys not to do that, you can use memory optimized or in-memory OLTP tables to store JSON columns, and I can compile, I can use native code to access it, and so I get all the performance benefits of memory optimized, which is really just about reducing locking and blocking, right? So typically in a web scenario where you're gonna use like a front-end web cache for session state, and it's highly transactional, I've got lots of inserts, lots of searches, lots of updates going on. This type of a table works really good because you don't get a lot of locks and blocks on it. It supports multiple readers to the table. And it has some other tricks behind the scenes with it. So it's built for very high scale transactional throughput. Anybody using memory optimized tables in SQL Server or heard of them before? So a couple people. I don't think, in fairness, like they're not quite fully baked, even though they've been around for a while. There's still a lot of limitations with it that make it where I'd want to use it in this use case, but oh, I'm using this spatial data type, so I can't use it, right? Or there's always some kind of trade-off there. But I definitely recommend, if you've got high concurrency and you see a lot of blocking, deadlocking, locking, explore whether you could put some of those tables into an in-memory OLTP table, right? So some resources. So this is my notebook resource. So you can go to my GitHub. So it's just github.com/JasonHorner, and then JSON on JSON. And the repo has this notebook in there. You can run these queries. There's really only a couple queries that really need the table. As you can see, everything was in variables. And I found this in here when I was reviewing the slides last week. I had no idea why I was messing around with this, but it was there, so I left it in there. And that's all I got. So we're a little bit early, about 15 minutes, which is a rare occurrence for me. Usually I go very long, but I'm happy to sit here, answer any questions, do karaoke. Okay.
Go back to your in-string example.
Okay.
You mentioned the query plans were pretty good. What data type does it convert? You had like 3, 0 decimal numerics there.
Ooh, that's a
So
good.
Does it give you in varchar, 4,000 or in varchar, whatever the length of them is, and you're not going to get devastated with the query plan.
That's a good point. I think it's.
Have the ability to specify that those
So what I could do, if I needed to coerce it, like in this case, I'm hoping SQL's smart enough to do the right thing and see it as an integer, but it may not, right? So in this case,
You don't have an example you can run. Hey, come on, type in it.
Oh man,
Come on, man.
if I had a connection, all right, oh, there we go, boom. So here, let's do this.
Let's see the query plan.
Well, so that's the dirty secret about this this tool, right? So hang on, we got this though. Wait, hang on, Control K, Z. All right, so we now go to the big boy query tool. Yeah, this is. We'll see. It'll probably take me 15 minutes to get this going, but I think I can do it. I feel like I'm auditioning. This is like the interview process.
You're welcome, Jason.
While we're waiting for this beast to load, are there any other questions? Yep.
In the updating section, I noticed
So when you say key, there's not really a key, like you can only update a scalar value with that, right? So it'll rename the property itself, but it won't work for like an object. I think if that's what you're asking.
Okay, so scalar value town. Town has like a string value, right?
Oh, you want to rename the town property? No, I can't do that.
Can't do it? Okay.
I mean, you always can do it, right? Just not through that mechanism. And a lot of times what I do is pretty dirty, is I'll grab the JSON back, string manipulate, push it back in.
Yeah.
So.
That's what I was afraid of.
Yeah. Good question though. Any others while I?
We have a question from online.
Okay.
It says, any performance considerations when using strict versus lax or certain patterns?
Not really. It's a good question. I think as me. Oh, thank you. So the question is there a performance difference if I do JSON value with strict or lax? And really it's a thing of correctness, right? Do I want it to error hard, so divide by 0, return an exception, or do I want it just to return a null? So I typically care about my data, so I'll try to put strict. But that being said, if I get lazy sometimes too, right? So I don't think there's a performance difference between the two, but there could be at some point in the future. Let's see here. Where is this? All right. Anything else?
Yeah, we've got one more here.
Okay.
Yeah, so I'm storing a ton of JSON, and I've been thinking about switching it over to SQL Server, but I'm not sure like how much benefits. I was looking at it specifically because I have more memory available.
Mm-hmm.
IO. So I was thinking about doing in-memory stuff, and I know that has its advantages. But other than that, you were talking about having a glob and storing it in SQL. Like, what's your advantage there? Like, what are you getting out of that?
As of
It's a lot more expensive to store stuff in Azure in the SQL Server than it is on a glob.
so let me try to paraphrase the question. What's the benefit of storing the JSON inside of a database versus on a file system somewhere? So it's a good question because normally the conventional wisdom would say, like, separate the two, right? Just use the database for the database stuff, put your files. So it depends on, oh boy, it depends on how you are going to interact with the data. If you're truly treating it like a document and it just needs, this is bad. I should have a password for this. Why isn't that not working? If I'm just going to bring the data back and then store it in the file system. But when I need to start querying it, then all of a sudden I got to bring the data back from the database, marry it with the data from the file system, crack open to the file in the client, and then search that way. I can't use SQL. So if you need to query it and run things like that on it, then that's where I think it makes more sense. That is lovely. Well, I thought I was connected earlier, so let me try one last trick. I promise I know how to connect to a database, but it's not in here. And
I withdraw the question.
well, it's a good. I almost guarantee that you're gonna get a scan. It's gonna treat those as integers. But where it would come into a problem is if you needed a date or something like that, and you need it as a date. I think it would treat it as a string like you think it's gonna do. So it's gonna use that implicit conversion, and you won't get maybe the behavior you want. But what I can do is I can cast that result as the data type. I think it'll work then. It'll give you the scan versus the seek.
I'll
Play around with it, but I'm pretty sure it'll do that. And I feel like if I didn't have this light shining in my face, I'd know how to type in my password, but maybe not. Other questions? Oh, speak now or forever hold your peace. So the question is, can I put a more advanced constraint on it rather than just checking for its valid? Is it valid JSON? Like, can I enforce a certain schema that, like, if if I have a customer object, does every customer object have a customer name, a customer birth date, so on and so forth? Is that accurate? So not easily, right? Now I can make arbitrarily complex check constraints. I don't recommend doing it, but I can actually use a function call, which is probably going to raise some eyebrows in here, in a check constraint definition. So I could create a UDF that actually does that validation. There's some performance overheads with it, and I think you get some inconsistent problems with it under cases. So imagine I create a UDF that goes in and takes a look at that JSON, inspects it, and comes up with a yes or no. It's either good or bad, right? So it returns true or false. That would work, right? Is it gonna, how robust is that gonna be, and what is the impact to performance would be something that you would wanna test, in my opinion. Yeah, good question. Actually, a really good question. I like it.
CLR, UDF
Yep.
would be the best option if you really had to do it.
Yep, good point. Others? All right, well, I think that wraps up my Star Trek experience. As short as sweet as it was. Hopefully it was a good session. Like I said, connect to me on LinkedIn. Ask me questions. I promise I know stuff. I can definitely troubleshoot your database connections and maybe do other things too. Anyway, I hope everybody had a great, everybody going to the movie? Is it tomorrow? Tomorrow night? The movie? Oh, it's tonight? Oh, well, all right then. I guess I'm all messed up. I had originally booked my flight for today at 5 o'clock because I thought the event was Saturday for some reason. So I woke up yesterday at 9. I was getting ready to go snowboarding. I was in my car. I got an email from the organizer saying, hey, the conference is tomorrow. I'm like, well, that's interesting because my tickets are for tomorrow too, but not at the right time. So I had a stressful 24 hours of rejiggering everything. So glad I was able to make it. Hope you guys enjoyed it. I really enjoyed. I'm gonna come next year and actually attend the conference. So anyway, have a good night and enjoy the movie.